No, you cannot use the neutral conductor to ground a 240-volt panel that only serves 240-volt loads. The purpose of a neutral conductor and a grounding conductor are distinct, and combining them improperly can create a hazardous situation. In a standard electrical system, the neutral conductor carries the unbalanced current back to the source, which is typically the transformer. The grounding conductor, on the other hand, provides a low impedance path for fault current to return to the source, allowing overcurrent protection devices like circuit breakers or fuses to quickly trip and clear the fault. When a panel is installed to serve only 240-volt loads and there is no neutral load, there is no need for a neutral conductor to carry current back to the source under normal operating conditions. The 240-volt loads, such as electric heaters or some appliances, use the potential difference between the two hot legs of a single-phase power supply, or two phases of a three-phase system. Because these loads do not require a neutral, it might seem tempting to repurpose the neutral conductor as a grounding conductor. However, this is a code violation and creates a dangerous scenario. If you were to connect the equipment grounding conductors of the 240-volt loads to the neutral busbar in the panel, and then connect the neutral busbar back to the source neutral, you would be creating a parallel path for neutral current to flow on the equipment grounding conductors. Under normal circumstances with no neutral current, this might seem harmless, but it introduces several potential problems. Firstly, if there ever were a neutral current due to an unbalanced load upstream from the panel, that current would flow through the equipment grounding conductors, potentially energizing the metal enclosures of the 240-volt appliances. This would create a shock hazard for anyone who came into contact with those enclosures. Secondly, if the neutral conductor were to become open or disconnected upstream from the panel, all of the neutral current would be forced to flow through the equipment grounding conductors. This could overload the grounding conductors, causing them to overheat and potentially create a fire hazard. Furthermore, it would leave the metal enclosures of the 240-volt appliances energized at a potentially dangerous voltage level. To properly ground a 240-volt panel that serves only 240-volt loads, you must install a separate equipment grounding conductor that is sized according to the National Electrical Code, or NEC. This equipment grounding conductor must originate at the service equipment where the neutral and grounding conductors are bonded together. From there, it must run along with the circuit conductors to the 240-volt panel. At the 240-volt panel, the equipment grounding conductor must be connected to a separate grounding busbar that is isolated from the neutral busbar, if one exists. The equipment grounding conductors from the 240-volt loads must then be connected to this grounding busbar. This arrangement ensures that the equipment grounding conductors provide a dedicated low impedance path for fault current to return to the source, without carrying any neutral current under normal operating conditions. It also ensures that the metal enclosures of the 240-volt appliances are properly grounded, minimizing the risk of electric shock. Refer to NEC Section 250 for specific requirements on grounding and bonding. These sections outline the rules for establishing effective ground fault current paths and minimizing voltage on metal pots. Section 250.4. A5 specifically addresses the requirement for effective ground fault current paths. This section emphasizes that electrical equipment and wiring must be installed in a manner that creates a low impedance circuit to facilitate the operation of overcurrent protection devices in the event of a ground fault. Section 250.24. C provides the requirements for grounding separately derived systems, such as transformers. While this section doesn't directly apply to a panel fed from the main service, it illustrates the principle of establishing a grounding electrode system at the source of power to ensure a low impedance ground fault current path. Size in the equipment grounding conductor is also crucial for safety and proper function. NEC Table 250.122 provides guidance on the minimum size of equipment grounding conductors based on the rating of the overcurrent protective device protecting the circuit. For example, if the 240-volt panel is fed by a 60-amp breaker, Table 250.122 would specify the minimum size of the equipment grounding conductor. It's important to consult this table and choose the appropriate size grounding conductor to ensure adequate fault current carrying capacity. In addition to the equipment grounding conductor, it's also important to ensure that all metal enclosures and non-current carrying metal parts are properly bonded together. Bonding involves connecting these metal parts together using conductors, typically copper, wires or straps, to create a continuous electrical path. This ensures that all metal parts are at the same potential, minimizing the risk of voltage differences that could cause electric shock. NEC Section 250.92 provides requirements for bonding service equipment. This section requires that metal enclosures, raceways, and other non-current carrying metal parts be bonded together to form a continuous electrical path. Section 250.96 addresses bonding other enclosures. This section requires that metal enclosures containing conductors be bonded together to ensure electrical continuity. When installing a 240-volt panel, it's essential to carefully follow the requirements of the NEC and local electrical codes. Improper grounding and bonding can create dangerous conditions that could lead to electric shock, fire, or equipment damage. Always consult with a qualified electrician if you have any questions or concerns about grounding and bonding. A qualified electrician has the knowledge and experience to ensure that your electrical system is installed safely and correctly. Grounding electrode conductors connect the grounding electrode to the electrical system's grounded conductor, typically the neutral bus bar, or to the equipment grounding bus bar, or both, at the service equipment. The grounding electrode conductor ensures that the electrical system is connected to the earth, providing a reference point for voltage and facilitating the flow of fault current back to the source. The size of the grounding electrode conductor is determined by NEC Table 250.66 based on the size of the service entrance conductors. The grounding electrode itself can be a ground rod, ground plate, underground metallic water pipe, or concrete encased electrode, often referred to as a UFA ground. The type of grounding electrode and its installation must comply with NEC requirements. Bonding jumpers are used to connect metal enclosures, raceways, and other non-current carrying metal parts together to create a continuous electrical path. Bonding jumpers ensure that all metal parts are at the same electrical potential, minimizing the risk of voltage differences that could cause electric shock. Bonding jumpers are typically made of copper or other conductive materials and are sized according to NEC Table 250.102. The proper installation of bonding jumpers is critical for electrical safety. Surge protection devices, or SPDs, are designed to protect electrical equipment from voltage surges or spikes, which can be caused by lightning strikes, utility switching, or other events. SPD divert the surge current to ground, preventing it from damaging sensitive electronic equipment. SPD are typically installed at the service entrance or at individual panels. The NEC provides requirements for the installation and wiring of SPD in Article 280. These requirements cover the location, type, and wiring of SPD to ensure proper protection. Ground fault circuit interrupters, or GFCIs, are designed to protect people from electric shock. GFCIs monitor the current flowing in the circuit and quickly trip if they detect a difference between the current flowing to and from the load. This difference indicates a ground fault, where current is leaking to ground. GFCIs are required in many locations, such as bathrooms, kitchens, and outdoor areas. The NEC specifies the requirements for GFCI protection in Section 210.8. This section outlines the locations where GFCI protection is required and the types of circuits that must be protected. Arc fault circuit interrupters, or RFCIs, are designed to protect against electrical fires caused by arc faults. Arc faults are dangerous electrical conditions that can occur when damaged or deteriorated wiring creates an unintended arc. RFCIs detect these arc faults and quickly trip to prevent a fire. RFCIs are required in many locations, such as bedrooms and living rooms. The NEC specifies the requirements for RFCI protection in Section 210.12. This section outlines the locations where RFCI protection is required and the types of circuits that must be protected. When working with electrical systems, it's essential to follow safe work practices to prevent electric shock and other injuries. Always to energize the circuit before working on it. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. Follow lockout/tagout procedures to ensure that the circuit remains energized while you are working on it. Never work on electrical systems when you are tired or distracted. If you are not comfortable working on electrical systems, hire a qualified electrician to do the work for you. Electrical safety is paramount. It's always better to be safe than sorry when working with electricity. If you are unsure about any aspect of electrical work, consult with a qualified electrician. They can provide expert guidance and ensure that your electrical system is safe and compliant with all applicable codes and regulations. Furthermore, understanding the specific requirements for your location is crucial. Local amendments to the NEC may exist, reflecting unique conditions or priorities within your jurisdiction. Checking with your local building department or electrical inspector can reveal any such amendments, ensuring your installation adheres to all applicable rules. Consider the long-term maintenance and inspection of your electrical system. Regularly scheduled inspections can identify potential problems before they become major hazards. Keeping detailed records of all electrical work, including permits, inspections, and any modifications, can be invaluable for future troubleshooting and maintenance. In conclusion, do not use the neutral conductor as a grounding conductor in a 240-volt panel serving only 240-volt loads. Maintain separation between neutral and ground, providing a dedicated equipment grounding conductor for safety. Always consult the NEC and qualified electricians.